Hello and welcome to today's geometry lesson. So we are going to be proving triangles congruent by side angle side. So can we get triangles congruent? So yesterday we found out that if we wanted to get triangles congruent, we needed to show that all 6 pairs of corresponding sides were congruent. So we had to get 3 angles congruent, and we had to get 3 sides congruent. So we're going to do an investigation here and see if there's anything else that we can do. So what I'm going to need you to have is a piece of paper, a pencil, a ruler, and a protractor. So I mentioned yesterday printing one off the internet if you were at home so that you would be able to get angles accurate. If that's not a possibility, then you could maybe use scissors and cut an angle to be exactly what you want it to be so you get it in 2 different triangles, because we're going to make 2 different triangles and we need a 50-degree angle. Okay? So stop this, get your materials, and then come on back when you're ready. Okay, what you're going to be doing is making a triangle, and it must be done in the order that I tell you. So you need to make one side to be 10 centimeters long. So obviously I'm just going to do this quickly here. So grab your ruler, mark that, and make this be 10 centimeters. And maybe mark it on the inside of the triangle so that you can compare it to another one. Okay, now we need to make another side 5 centimeters. But the big kicker is you need to get the angle between them to be 50 degrees. So if you go over here and you want to make this side right here your 5 centimeters, that's great. But this angle right here needs to be 50 degrees. So grab your protractor, mark this off, and if you extend this however long you make it, it doesn't really matter. But then grab your ruler and mark up so that it's 5 centimeters, and then just connect it to this point here, and then I want you to cut out this triangle. Okay, so go ahead and do that. So stop the video, go ahead and do that, and then come on back. All right, now we're going to go through it and we're going to do the exact same thing. So in class, I would just have you do one of them, and then we'd have 35 triangles all made, and then I would collect them. But you really only have to compare it to yourself. So I'm going to start this time with the 5 centimeters. So I'm going to mark off and I'm going to do 5 centimeters. All right, then just because I want to do it different, I'm going to make the 50-degree angle here. So this is what I was talking about. If you do a piece of paper and cut it off, if you line this up and then wherever you are, just cut it so that it goes over here, so you can just cut something if you don't have a way to get a protractor printed. Now, when you make this side, so when you mark this 50 degrees and you make this side, make sure that it's long enough. And then now grab your ruler and then mark off so that this side right here ends up being 10 centimeters. And when you're done, connect this point back to the beginning to this point and cut this out. So now you should have made 2 different triangles with 5 centimeters corresponding, 10 centimeters corresponding, and that 50-degree angle between. Now, put them together, rotate them, flip them, whatever you need to do, but are these triangles congruent? Can I flip them? Can you flip them around so that they lay on top of each other and they match up so that the corresponding 5s are lined up, the corresponding 10s are lined up, and the corresponding 50s are lined up? Does this side that you made between these 2 points, is it the same as everyone else's, as your other one? Are those 2 sides the same? And if you were to measure this angle right here and this angle over here, is that going to be the same as everybody else that just made the same triangle? And then this corresponding one over here, are they going to be the same? And the answer is yes. So they are congruent. Even though we made them on opposite sides, we started with different numbers, they still end up being congruent. And what this is called, the side angle side theorem. Okay, side angle side. And you know mathematicians, they're always looking for a shortcut. So what they do is call it SAS for side angle side. Now, it is super important that that angle is between the two sides. We call this the included angle. Included angle. Okay, so we're not talking about, oh, this is 5 and this is 10, and then over here we put the 50-degree angle. That's not what we're talking about. Do you see how that included angle is between the 5 and 10? Okay, and the same thing over here. It must be included between the two sides that you made your 5 and your 10. And this is called the side angle side congruence theorem. So this is what this is reiterating. The sides need to be in order. So if we use this side and we use this side, we now do not have a choice. This angle is a no. This angle is a no. We must use this one because it is the angle included between the other two sides. All right, so we are going to start writing our proof. So stop the video, get this stuff into your notes wherever you're doing this, and practice writing this proof. So we are trying to get these two triangles congruent. Now, yesterday when we were doing this, we would have had to show all 6 corresponding sides, 3 angles, 3 sides, were congruent. But we just found out today we only need to get 3, and it's a specific 3, a side, an angle, and a side. And if you look here, they're already giving us a side. So they're already telling us that BC is congruent to DA. That is given information. So we already have one side down. Now we need another side and another angle. So is there anything else that this diagram is telling us? Well, they told us here that BC is parallel to AD. So this top side, BC, is parallel to this side. Now, how is that going to help us? Well, if we think back to some other math things that we've been doing this year, if we have 2 parallel sides, we've talked about putting a transversal down between them. And if we have 2 parallel sides, and does this angle have a special name for that one? So, I believe we can call that angle BCA is congruent to angle. So BCA is congruent to angle CAD. Why? Because we have those parallel lines cut by a transversal, don't we have alternate interior angles here? And alternate interior angles are congruent. So now we have a side marked congruent. We have an angle congruent. So is there a way for us to get another side congruent? And isn't AC congruent to AC? And isn't that called the reflexive property? So by reflexive, AC is congruent to AC. Well, now we have 3 sides, or 2 sides and the included angle. So can we say triangle ABC is congruent to triangle, so ABC, so it looks like its corresponding side is CDA, and by what? What's our reason? Well, we just had a theorem that's called side, angle, side. So by side, angle, side, those 2 triangles are congruent by getting the 2 corresponding sides and that included angle congruent. All right, last problem of the day. So we're given a circle, and now we have a triangle MRS and MPQ. Are they congruent? Well, they're telling us they are, but what would our explanation be? Why are they congruent? Well, what do we know about circles? Circles have diameters and what? Radii. So what do we know about MS, MR, MP, and MQ. Are all those radii of the circle? So are all four of those pieces congruent? All right, and then we have another thing in here. What about this angle right here and this angle right here? Are those two angles congruent? And aren't those vertical angles? So we can get SMR congruent to PMQ because those are vertical angles. And now, don't we have side, angle, side, side, angle, side? So wouldn't those two triangles be congruent by side, angle, side? Okay, then the last thing they want us to do for today is solve for x. So they're telling us that QS, so this big long piece, QS, is 12x. And isn't that a diameter? And then they also tell us RM. So RM is 8x. Now RM is a radius. So is the radius equal to the diameter? And the answer is no. I need how many radii? Whoops, I forgot my 48. 12x plus 48. How many radii do I need to be equal to the diameter? So I can't just put an equal sign in here. But if I double this radius, then they're going to be equal. So 12x plus 48 is equal to 16x. So if I subtract 12x from both sides, I get 48 equals 4x. And now if I divide both sides by 4, it looks like x is going to be 12. So I don't think they asked for us to find any other lengths. They just wanted us to solve for x. So in this particular case, we are done. But remember, most of the time they're going to ask you to go back and find the length of something like MP. So what would the length of MP be? Well, MP is the same length as RM. So we would take 8 times 12. So what's that going to give us? 96 units. So just make sure you're always answering the question that they want you to. All right, good luck on your homework for today. Have a wonderful day.